Hello, in this video we're going to talk about thermodynamic properties and how they're related to one another and how we can think about kind of some of the different classes of thermodynamic properties. So if you look at your phase diagram of a material, it might look something like this. Right? This is the one that we most typically see, temperature and pressure. And it might look something like this, where we would have a solid, a liquid phase, and a gas phase. Now we can think about the phase diagram of a material or the state diagram of a material like this, but we can also think about it, say, pressure and down here on the x-axis, specific volume. And then our diagram would look something like this, where over here we would have liquid, over here we would have gas, up here would be the critical point, right, which the critical point on this phase diagram is right there. We'll talk more about the critical point later. It's kind of a fun point where basically beyond which there's no distinction anymore between liquids and gases. So kind of a fun one. We're not going to talk about it too much more right now. So one of the challenges that we'll find is we're going to be talking a lot about properties of materials and defining the properties, the thermodynamic properties of a material. So if we think about how we can do that, what we need to define our state, we need two independent properties. And I'm going to underline both two and independent. Okay, so basically what are we trying to do? We're trying to find the, one way to think about it, we're trying to find the specific point, say this point here, on these graphs. So this would be defined, that point would be defined by that temperature and that pressure, T1 and P1. So those would be two independent properties, pressure and temperature, that would define that state. Likewise, we could have two different independent properties. Say we'll define this guy right here, where they could be defined by the specific volume, and over here, the pressure. And we need independent properties. That means that no two states share the same two properties. So the easiest way to visualize this is with liquids and gases. So if we look at, well, let me finish writing this. No two states share these. So what we mean by independent. So I'll do the next little bit in green. So if we say these 2 points, well, let's simplify it. Let's do right on the line. So point A, and here in red, point B. So for point A, right, these can be defined by point A could be defined by PA and specific volume of A and say the temperature of A. There are other things we could define too, like the enthalpy and entropy and internal energy. We haven't talked about those yet, but there are other things that other properties that we could define. And we could define B right, with PB, and so this is point B, PB, specific volume of B, and the temperature of B. So for these 2 points, obviously they're not the same. So A would be a liquid that's just about to boil. B would be a vapor that's just about to condense. So A is just a liquid. B is completely a vapor. So clearly they're not the same. Liquids and vapors are not the same. But they actually share 2 properties. So PA is equal to PB. We can see that directly there on the graph, that they share a pressure. They also share a temperature. So we said temperature is another variable, but TA is equal to TB, right? So a liquid, if we think about what's going to happen when it boils, if we boiled A all the way to B, well, it's going to boil, we're boiling at constant pressure. So that means that temperature would be the same. So the temperature of state A and the temperature of state B are exactly the same. So for a vapor liquid mixture, temperature and pressure are not independent. If I could spell. Okay, so if we have something like a normal liquid or a normal vapor, then temperature and pressure are independent. But for something that's boiling, temperature and pressure are linked because it's boiling. So we would need 2 different properties. Right here, we define them by the independent properties, pressure and specific volume. Now, the other thing to note about the thermodynamic properties are extrinsic versus intrinsic properties. For an extrinsic property, and I'll just write here the value, that's kind of what we would colloquially call this, the value or the amount of the property depends on amount. By amount, we mean mass, typically. For intrinsic, write the same, but does not depend on the mass. So an intrinsic property is intrinsic to that state. It doesn't depend on how much of the substance you have. An extrinsic property does depend on how much you actually have. So just some examples. Intrinsic would be something like temperature, pressure, specific volume, and then I'll write some other ones, lowercase u, lowercase h. Again, we don't need to know what those are. For our book, these are called specific properties. In our book and this class, we'll use lowercase letters. Okay. For extrinsic properties, this would be something like volume, and then you'd use like capital U, capital H. So these we use uppercase. Okay, and let's look just at the case of volume. So this is just an example. Just looking at the case of volume. So the extrinsic quantity volume, obviously the volume of a substance depends on how much you have. So total volume would have units of, say, something like meters cubed. And it depends on quantity. So that's obviously, this is extrinsic. Now the intrinsic corollary to that would be specific volume. This has units of meters cubed per kilogram. So you can think about it, this is independent of quantity. So this is intrinsic, right? It doesn't depend on how much we have because it's the per kilogram amount. So this is like space / volume per mass. And when we're talking about thermodynamic properties, typically we care about both extrinsic and intrinsic properties. The terminology can get a little bit confusing, but if we think of the intrinsic quantities, we can look these up. And we can look those up because those are going to be independent of anything else in our problem, right? It doesn't matter if we have one problem or another problem, those are intrinsic to the quantity. So those are going to be things that we can look up, say, in thermodynamic tables. Extrinsic properties, we have to calculate. And we would have to calculate those specific to each individual problem, or we would have to be given those specific to the individual problem. We can't look up extrinsic properties because those are going to change depending on how much of a substance we have. So hopefully that gives you a little sense of some of the kind of key aspects of properties, right? If we want to find all of the properties for a given substance, we need to know at least two independent properties to define that state. So something like temperature and pressure, although that doesn't work for a vapor-liquid mixture, we would need, say, pressure and specific volume, or temperature and specific volume, or temperature and enthalpy. There are a lot of different pairs that we'll talk about in this class, but we need two independent ones. And then just the difference between intrinsic and extrinsic properties, where intrinsic ones those are going to be the properties that we're looking up in tables. Often they'll have units of per mass, or there'll be things like temperature and pressure, which, right, if you have twice as much water, it's still going to be at the same temperature. Temperature doesn't scale with the amount you have, and neither does pressure. If you have 1 atmosphere pressure in a classroom, if you go outside where there's a lot more air, you're still at 1 atmosphere pressure. It doesn't matter what size you're talking about, pressure is independent.